Okay, let's talk about these two integrals. The first one is the integral of 1 over secant x plus tangent x. And for the second one, we have this on the top, and the denominator is still the same. Well, think about it. Which one's actually easier? And also, keep in mind, you should pause the video and try these two questions first before you watch the solution, alright? But anyway, let's take a look right here. It looks like this might be easier because on the top is just 1, but you have to really remember what I'm going to tell you. Sometimes when you are doing integrals, the more the better. This right here, it's more straightforward. And the reason is because if you look at the derivative of secant x is secant x times tangent x, and the derivative of tangent x is secant square x, and you can just add them up. So we can do this integral by u sub right away. Let u equal to the denominator, and let's just put down secant x plus tangent x, and differentiate both sides. Du, the derivative of this is secant x times tangent x, and we add the derivative of this is secant square x, putting in parentheses, and of course the dx. And you see, this and that are actually the same. The order of addition doesn't matter. So, you look at the top, all this right here along with dx, this right here gives us precisely the du. So we can look at this right here as the integral. And I like to put a 1 on the top and then a d whatever on the side. So let me write that down as 1 over. The denominator here is our u. And all that, it's going to give us du. So we can totally integrate this now. And the integral of 1 over u in the u world is just natural log of absolute value of u. So let's put that down. And because we know u is this, so we can just put that down right away. So we have the secant x plus tangent x inside, and then we are done. Put a plus c. This right here is it. In this case right here, before I show you guys this one, right here, do not factor out the secant x and then cancel things out. In fact, this question right here, it's precisely how we integrate secant x dx. We get this actually. So here's the deal. If you integrate secant x, what you are going to do is you are actually going to multiply the top and bottom by secant x plus tangent x. Let me just write this down right here for you guys real quick. Secant x plus tangent x, like this. And as you can see, because if you want to integrate secant x, you don't have too much things to work with. When you multiply this right here, it's just about right. No more, no less. And you end up with the integral of secant square x plus this times that, which is secant x tangent x all over this denominator. So this is actually the way that this should be a dx. This is actually the standard way to integrate secant x, and this right here is a standard result, right? And now let's talk about how we can do that. Well, in this case, if you let u equal to a denominator, unfortunately, the top is just 1. We don't have this, right? And you don't want to multiply top and bottom by that. So here's how we can do it. We can write everything in terms of sine and cosine. This is also a strategy. Keep in mind, in an integral, the sine and cosine, they get along with each other really well. They are like the best roommates. So let's see. This right here is just 1 over. This right here is 1 over cosine x plus tangent is the same as sine x over cosine x. And of course, we can put on the dx right here. And notice, I can just clear this complex fraction by multiply the top and bottom by cosine x. So that this way, on the top, we get a cosine x. On the bottom, this times that, we have 1. This times that, we just have the sine x dx. And right here, we can just go ahead and do u sub. I'll just put it down right here real quick. U equal to the denominator. That u equal to 1 plus sine x. Because if I differentiate this, the derivative of sine x is precisely cosine x, right? The derivative 1 is 0, so we have this, and then we have the dx. Same thing, this is so nice. The top, cosine x, dx, this is our du. So again, we end up with the integral. Let me put a 1 on the top, and the bottom is precisely our u, and all that is the du. So in this case, we also have the natural log absolute value of u, and we know u is this, so we can just put it down right away. 1 plus sine x. And with that, we are done. So that's it. Okay, here we have these two integrals, and as you can see, for this one, we have sine square x, and for this one, this is just sine to the first power x. Let's see. Both of them on the top, they have the cosine x. And we know the derivative of sine x gives us cosine x, so that's a big hint. I think this right here is actually easier for me to demonstrate, so let me do this first. I will just take the u to be 1 plus sine x, because if I differentiate 1, I get 0 anyway, so I'll have the 1 right here as well. So here we go. Let u equal to 1 plus sine x, and then du equals derivative 1 is 0, and the derivative sine x is cosine x dx. And as we can see, on the top, we have exactly cosine x times dx, and that is our du. So that's nice. And with that being said, we can take this to the u world right away. The integral, and we have 1 over. This right here is just u. And then all that is our du. So right here, we can just say the answer is natural log of absolute value. Inside is just u, and you put this back for the u, 1 plus sine x. And we are done. That's it. Well, for this one, if you let u equal to the whole thing, let me just put this down right here for you guys. If you let u equal to the whole denominator, 1 plus sine square x. This is not so good, because when you differentiate this, the derivative 1 is 0. The derivative of sine square x, don't forget to do the power rule and also the chain rule. You have to bring the 2 to the front, so you have 2 sine x to the first power, and you have to multiply by the derivative inside, so you end up with another cosine here. This and the top, they are not exactly the same, right? I don't think this is going to work out nicely, so I'm not going to continue. So here's the deal. Don't forget this right here means sine x in the parentheses and then square. So I will just write this down right here for you guys real quick. Cosine x over 1 plus parentheses sine x and then square and then dx. With that being said, let me just take u to be sine x. And this is going to work out really nicely as well, because du is equal to cosine x dx. Just the inside, okay, just the inside. And then you see that on the top, we have du again. So that's really nice. So now, this is the integral. On the top, I'll just put down 1 over, and then the du will be on the side right here. And for the denominator this time, we will actually get 1 plus, and this is the u. So we have the u square like this. And you have to ask yourself, the derivative of what will give us 1 over 1 plus u squared? And the answer for that is inverse tangent. So this right here gives us inverse tangent of u, and u is sine x, so I'll just put that inside right away, like this. Okay? And we are done. Put plus c, and this is it. Okay, let's take a look at these two integrals. The first one is tangent of 2x times secant of 2x. And for the second one, the 2's are at the different places, and they mean different things, of course. Here we have tangent square x times secant square x. Let me actually show you guys this one first, because I noticed the angle, the 2x's are the same, and the derivative of 2x is just 2 times dx. That's nice. Right here, I can just go ahead and let u equal to 2x. It's just going to be du equal 2 times dx. And in this case, let me divide both sides by 2 so I can isolate the dx. And I want to do that because I cannot pair up 2x. So this way, it will help me to know if I have to divide or multiply, right? So let me show you. Take this integral to the u world. We get the integral tangent of, inside is the u now, and then here we have secant of the inside is again the u, and the dx, as I mentioned it, is du over 2. So this is nice. And now let me clean things up for you guys. We have a 1/2. This is just a constant multiple. We can put that all the way in the front. So let me write that down. And then we have the integral. This is tangent u times secant u. Maybe we can tweak the order so we can recognize it better. Let me do that for you guys. Let's write it down. Secant u times tangent u in the u world. What's this? Yes, it's just going to be secant because the derivative secant is precisely secant times tangent. So 1/2 is still 1/2, and the integral of all this is just secant, and the input is u. And let me just put the 2x back now. Save one step if you do that, and we're done. Plus c, and this right here is it. Well, for this one, it's weird. Well, let's see. Don't forget this means tangent x squared and then secant x squared. But for this, here's the idea. Let me just use u equal to tangent to the first power x. Because I know when I differentiate this, the derivative tangent x is precisely secant square x dx. Right here, I can also isolate the dx. But I notice we have secant square x dx right here. So this is nicely equal to our du. So I can put this back as the integral. Tangent square x, this is the same as u square now, right? Because u is tangent to the first power. So tangent to the second power is just u square. And for the du right here, this is good. Like this right here, I can go ahead, I will just add 1 to the power, which is 3, and then divide it by the new power. So I have that. So we get 1/3, and let me keep it as u to the third power first. And then I will put the tangent back right here. So altogether, we get 1/3. U is tangent x, so I'll put down tangent, and then the third power right here, and then the x right here, and then we are done. Put plus c, and this is it. Okay, let's take a look at these two integrals. Again, they look so similar, but for this one, we have the -1 inside of the square root in the denominator. Let's do that one first. Even though this right here is more, but sometimes more is too much. So let's do this one. First of all, in calculus, it's almost always a good idea to look at square root as 1/2 power. So let me just put this down right here for you guys. I will look at this as the integral of 1 over parentheses to the 1/2 power, and then the inside is of course still the e to the x like this. When we do that, of course we can multiply the powers. In another word, we get the integral of 1 over e, and x times 1 over 2 is of course just x over 2 like that. And here we have this in the denominator. We can bring that up to the numerator and use negative power. So this is the integral e to the negative x over 2 power dx. And now, check this out. Well, we have e to the something, and here we have negative x over 2. The derivative of negative x over 2 is just negative 1/2. It's just a constant multiple of dx. So that's good, because this is pretty easy now. We will just let u equal to this right here, which is negative 1/2 times x. Right? Let me just put this down because it's easier to see when I differentiate this. I get negative 1/2, and we have the dx. In this situation, I don't see negative 1/2 somewhere, right, in the front, so I will just divide. I will just isolate the dx. And to do so, I will multiply both sides by negative 2, right, so that I can cancel this out. So I will get negative 2 du. And now, This right here is the integral e. This is my u, and dx is that. And this is a multiplication, negative 2 du, like this. And we can clean things up a little bit more. We can put the negative 2 in the front, and then the integral e to the u du. And then we can just go ahead and do this. This is negative 2. And the integral of e to the u is still e to the u. So we can just put this down as e to the u, which we can just put this down right here. And let me write it down as negative 1/2 x. And we're done. Put plus c. So this wasn't too bad. Now let's take a look at this right here. This is not going to work for us, unfortunately. So we have to do some hardcore u substitution. This is how. You can try to let u equal to the inside, but let me tell you guys that if you let u equal to the whole denominator, it's actually going to be better. And the answer to this is not going to be ln, absolute value of square root of e to the x minus 1. No. But anyway, let me put this down right here for you guys. I'm going to let u equal to the whole denominator, which is the square root of e to the x minus 1. So now let me just go ahead and take the derivative. So we have du, and the derivative of square root is 1 over 2 square root of the inside. So let's put that down right away, like this. But the chain rule says we have to multiply by the derivative inside. The derivative of e to the x is still e to the x, and the derivative of minus 1 is 0. So this is what we have. And of course, let's put down the dx. Now, this is the time that we really should isolate the dx. And to do so, well, this is on the top. Let me just multiply by the reciprocal on both sides. So we get dx being this on the top now, 2 square root of e to the x minus 1 over this on the bottom now, like that. And we will have the du like this. And yes, notice that this guy is the u. Sure, that's okay. Well, let's go back to the integral and see what happens. Right here, we have the integral. 1 is still 1 over. This is my u, so let's go ahead and put that down. Dx is all this. And notice that if you change this back to u, they cancel each other out. So that's nice. So I will actually write down 2u over e to the x, and then the du, like this. So far, so good. Everything works out pretty nicely. And we see that the u's cancel each other out. But here's the trouble. E to the x. The x is not allowed in the u world. So we have to do a few more things. This right here doesn't mean that this is wrong. It's just that we have to continue to do more things. Well, what do? We know that u is equal to square root of e to the x minus 1. So in fact, we can solve for e to the x from this equation. Let's square both sides, so we get u squared equals the inside, which is e to the x minus 1. And of course, we can add 1 on both sides. So this will tell us e to the x equals u to the second power plus 1. So that's nice. So now let's put things down together. Let me draw the integral sign. And let me put a 2. It's just a constant multiple all the way in the front. 1 is still 1. Over is still over. But e to the x right here is u squared plus 1. If you want, you can also put down 1 plus u squared. Perhaps it's more recognizable this way. Doesn't matter. This is what? It's not natural log anymore. This right here is inverse tangent, right? So we know this is 2. And altogether, we get inverse tangent of u. But u is what? This guy. So I'll put that back. Square root of e to the x minus 1, like this. So with that, we are all done. This right here is it. I would recommend you guys to just erase, I would recommend you guys to write this down on a different sheet of paper and try to do it from scratch again to see if you can redo the question without any help. Right? That would be a really good way to practice. But I'll leave that to you guys, and at the moment, this right here is it. Okay, so we have 2 integrals on the spot, and yes, They both have the 1 on the top, but the answers are not just going to be natural log of the denominator, natural log of the denominator. No, even though you put the absolute value, still no. Because you have to remember, 1 over u, the integral for that, will give us natural log of absolute value of u. But here, you have square root of x. It's different, okay? So don't be addicting to the natural log business, especially you see the 1, right? It's a dangerous addition. Anyway, here we go. I believe in u sub, even though I don't see a lot of things can be cancelled, but seriously, I believe in u sub, so I'll take u to be, perhaps let's just do it with the denominator, 1 minus square root of x. And let me just follow the usual step. I will differentiate both sides. Du and the derivative of this is negative 1 over 2 square root of x dx. And I want to isolate the dx. Let me just multiply this on both sides. So I get dx being negative 2 square root of x, and over there we have that du. And now we can take this integral to the u world. We will see this is the integral 1 over the denominator is u. Du is all this, and keep in mind it's a multiplication, so I will put on multiplying by negative 2 square root of x du. Unfortunately, u and square root of x, they don't cancel out. And the worst thing is that whatever x right here, it's not invited in the u world. But it's okay, because in fact, we can look back to the original equation and isolate the square root of x. Look at this right here. We know u is equal to 1 minus square root of x. I can just move this to the other side and move the u to the other side. I can get square root of x equals 1 minus u. And I can put this for the square root of x. That would be nice. All right, now let's see. I will put the negative 2 because it's just a constant multiple all the way in the front. Like that. And then the integral, and this is 1 over u. And for the square root of x, I will have to do this, put parentheses 1 minus u. And we are in the u world. That's nice. And now, right here, of course, you can look at this as distribute the 1 over u to the inside, or you can look at this as 1 over u minus u over u, either way. And you will end up with negative 2 integral. This and that is 1 over u. This and that give us minus 1. Put a parentheses, du. We can finally integrate this guy. Now, let's see. Minus 2 all the way in the front, and put down a parentheses for the result integrations because we have 2 parts. The integral of 1 over u give us ln absolute value of u. Now, this is legit, okay? And then the integral of 1, you have to know which world you are in. You are in the u world. So you do minus u right here. And we are done with the integration step. And we will just put this back for the u, right? And everything will be nice. Now, let's see. We have negative 2 parentheses, natural log absolute value, and the u is 1 minus square root of x. I will have to keep the parentheses because the inside 1 minus square root of x could be negative. So keep it, and then minus the u is 1 minus square root of x, and of course in the parentheses, another parentheses. So this is pretty much it. You can put on plus c, but perhaps I will distribute the 2, right? So you just do the usual business, multiply it, do it carefully, and we will have this and that, which is negative 2 ln absolute value 1 minus square root of x. This times that is positive, and you have the 2 times this, which is going to be plus 2. This times all that, negative times negative is positive, times another negative, so it's negative. And you have the 2 square root of x, like this. So you're all done. Right here, you can put a plus c. If you want to leave the answer right here, that's okay, but I will label this as c1. Because I notice I have another constant here, namely just a 2. 2 plus c1, you can merge them together. A constant times a constant is just a constant. So you can write this down as, perhaps I'll do this in blue so we can see the difference. It's okay to write the answer as negative 2 ln absolute value 1 minus square root of x. And then just keep the function part. So you have the minus 2 square root of x. But this and that together, you will have to say that's another constant, C2. So just like that. Perhaps I'll box this right here for you guys. But of course, if you leave the answer right here, this is okay as well. Right? But just don't want you guys to fight with other people if they do end up with this answer, and this is how they get it. Constant, constant, another constant is another constant. That's it. And you do this a lot in differential equation, which is coming up soon. Now, let's take a look at the second one. This time, I'm not going to use substitution because I notice we have 2 square roots in the denominator. Why don't we try to multiply by the conjugate? And it actually will work out really nicely. So let me do that. Multiply this by the conjugate, which is square root of x plus 1, and the middle is plus square root of x, just like that. Do the same on the top, square root of x plus 1, and then plus square root of x. So do this first before I do any whatever, right? Now, let's see. On the top, it's just that, but on the bottom, check this out. This times that, because you have multiplied by the conjugate, all you have to do is the first term square, right? The first term square. So I will just write this down. Square root of x plus 1, you square that, and you minus the second term, you square that. On the top, let me just leave it as how it is. Square root of x plus 1 plus square root of x, like that. This is so nice because this and that cancel, this and that cancel. You just get x plus 1 minus x, and then x minus x cancel. So on the bottom, you pretty much just have 1. That's it. Nothing else, just 1. So when you divide this by 1, doesn't mean you don't have to worry about the 1. So now you have the integral. This now is much better. I will look at this as parentheses x plus 1 to the 1/2 power, and we add this right here. I will look at that as x to the 1/2 power dx. Here's the deal. If you look at this term, we have inside x plus 1. If you set this to be u, du will be the same as dx because the derivative x plus 1 is just 1. When you have a constant multiple and you see this right here, you can just do the power rule right away. You don't have to let u equal to this. Anyway, I'll go ahead and do that. So I'll add 1, which is 3/2, divided by the new power, which is 2/3. Likewise here, I add 1, which is 3/2, divided by the new power, which is 2/3, right here. And we're done. I'll write this 2/3 and x plus 1 to the 3/2 power, and we add 2/3 x to the 3/2 power. And if you would like, you can change this back to the square root notation. It's okay. So perhaps I'll do that right here for you guys real quick. This is the same as 2/3. The half power is the same as the square root. And you can write this as x plus 1 to the 3rd power. And you can write this as plus 2/3. Again, look at that as the square root, x to the 3rd power plus c. So they are equivalent, so the c are the same as well. So anyway, up to you. This right here, they are all legitimate. And perhaps some people will be noticing that, hey, you have more power in the square root, so you should factor something out. Yes, if you want to do that, then this right here is 2/3. You take, x plus 1 to the 2nd power in the square root out, which is x plus 1 to the 1st power out, and then you have the square root of x plus 1. Same business. And this right here is just algebra, so I'll leave that to you guys. X square root of x plus c. So I'll do this right here. Yes! Just like that. Let me know which one you guys prefer. Whew, that's it. Okay, now let's take a look at these two integrals. And as you can see, they look similar. This right here is 2 to the inverse tangent of x as the power, and this right here, the inverse tangent of x is the base, and then the 2 is the power, and then the denominators are the same. In fact, they are really similar, but you also have to know one little thing for that integral. So actually, let's do this one first. This is actually easier. Let's actually do this one first. Why not? Because I said this is easier. So here we go. I will let u equal to inverse tangent x. Why? Because it works. Because when you differentiate this, you get 1 over 1 plus x squared dx. And you do have this right here. If you want to see a cancellation, just go ahead and multiply this on both sides. So you can get dx being 1 plus x squared, right? Times the u. So you can take this to the u world and you get integral. This is the u. So on the top is just u squared and the bottom is 1 plus x squared. But the dx is this, which is 1 plus x squared du. And as I told you, it works. This and that cancel out very nicely. So you're just having the integral of u squared du. And for this situation, let me actually just write it down as 1/3 u to the third power first. Because the u is the inverse tangent. I will put that back right here, and we get 1/3 parentheses inverse tangent of x and to the third power like this. And we're done. Put plus c. Right, so this is what I want to tell you guys. First, do not multiply this and that because this right here represents the inverse tangent. This does not mean 1 over tangent x. So do not write, don't write, please do not write, don't ever write, just don't. Don't ever put down tangent to a negative 3 power like this and x. No, just don't. In this situation, just write it down with the parentheses. Inverse tangent of x inside, raised to the third power, and then of course we have the 1 in front. And then of course we have the plus c. Alright, now this right here, it's pretty much the same thing. You let u equal to inverse tangent of x again. And then du is of course the same thing as what we have over there. And perhaps let's see the cancellation again. We get 1 plus x squared du. Now take this to the u world. This time though, we end up with the integral. Top is going to be 2, and then the power is the u, and then of course the base is 1 plus x squared, and dx is this, which is 1 plus x squared du. Cancel out. Now here's the deal. We have to integrate. This is not u squared anymore. This is 2 to the u power du. So you have to know how to integrate by using the power rule, and now this is the exponential version, exponential rule. So here is what you have to remember. Perhaps I'll put this down right here in blue for you guys. Remember, yes, e to the u is easy, but 2 to the u, you do the following. And let me remind you guys, if you differentiate b to the x power, where b is a good base, okay? This right here gives you b to the x times natural log of b. And when b is the special number e, then you just get e to the x. Well, if you integrate b to the x dx, instead of multiply by ln b, you divide it by ln b. That's pretty much it. So you put this down, which is b to the x, but you divide it by ln b, and of course put a plus c. So to do this, you actually have 2 to the u repeats, still on the top like this, but you have to divide it by, the base in our case is 2. So you have to divide it by natural log of 2, like that. In the end, you have to look at what u is. U is of course that, so we'll just put this back. So 2 to the inverse tangent of x all over ln 2. And when you just have 1 inside of the natural log, it's okay for you guys to not put down the parentheses. So that's it, but it's not okay for you to not put down the plus c. So anyway, that's it. Okay, now we have these two integrals. Well, it's the algebra. It's not any of the integration technique, okay? Because for example, this one, don't do u sub. It's not going to work out nicely. You don't have to do u sub. You can just do algebra. So what you do is you just multiply, And you know, the good old days where you can just multiply things out, and that's the whole question, isn't it? Anyway, integral, and when you do this times that, you get x to the fourth power, and when you do this times that, you get x to the third power. When you do this times that, you get x, and when you do this times that, you get 1. So just multiply it out. So you see that you have this plus that plus that plus that. You can just integrate them term by term because it's just additions. So the first one you get 1 over 5 x to the fifth power. The second one you get 1 over 4 x to the fourth power. This one you get 1/2 x squared, and then to get 1, well, in the x world you get x. So you're done. Put plus c like this. Alright, now take a look at this one though. We have x to the third power plus 1 over x plus 1. Yes, we can factor this out. So let me write this down right here for you guys to just remind you guys to factor out the sum of two cubes. When you have a to the third power plus b to the third power, this right here is equal to a plus b times a squared minus ab plus b squared, like that. In our case, we have x being the a, and the 1 is the same as 1 to the third power. So we can totally factor this out. We get the integral, we get x plus 1 first. Hey, this is going to cancel nicely, huh? And then the rest is going to be x to the second power, and then minus x times 1, which is just x. And then in the end, we put on plus 1 squared, which is just 1, like that. So we use this formula to factor this out. Over x plus 1, of course, still dx. And then, of course, we have to cancel out this and that. Very nice, very nice. And in the end, we are just integrating x squared minus x plus 1. And we pretty much do the same thing. This is going to give us 1/3 x cubed. And we get minus 1/2 x, and then we get x. And don't forget the plus c. That's it. Okay, we have these two integrals. That one's easier because I notice on the top I have 2x to the third power. On the bottom, 1 plus x to the fourth power. If I differentiate the bottom, this is going to give me 4x to the third power. And the x to the third power, can be cancelled out. So I'll proceed by taking u sub and let u equal to 1 plus x to the fourth power, and then differentiate both sides. Du will be 4x to the third power dx. And let me show you guys a cancellation. So I will isolate the dx by dividing this on both sides. I get du over 4x to the third power. And now let's put this back, and we'll see this is the integral. On the top, I'll keep it 2x to the third power over. The bottom is going to be the u, and the dx is this, namely du over 4x to the third power. And as you can see, the x to the third power, they cancel each other nicely, and 2 and 4, of course, we can reduce that to be 1/2. So we can take that 1/2 to the front, and we have the integral of 1 over u du. This right here is just natural log. So here we go. We have 1/2 natural log of u, and u is this guy, so let me just put it back right away. Let's save one step if you do this. And notice x to the fourth power, it's always positive, and you add 1 to it, it's always positive. So you can actually just use the parentheses, and you are done. This right here is the answer. That's it. Now, for this one, it's slightly trickier. Because if I differentiate this bottom, I get, 4x to the third power. This time on the top, I only have 2x to the first power. Think about it. When you have 2x, I wish to see some x squared somewhere around here, so that if I can set that to be the u, the derivative x squared will give us 2x. That would be nice. I don't see any x squared though, but yes, we do have it. Because if you look at x to the fourth power, we can write that down as x squared squared. And let me put that down right here for you guys. We can look at this as 2x over 1 plus parentheses. This right here as x squared and squared. How is this? Yeah, this and that are still the same. from here, I will just set my u to be this. Let u equal to x squared. So du will be exactly 2x dx. And since this is exactly what we have on the top, so I will just group them and say that's the du. So we have the integral. I have the 1 on the top over 1 plus. This right here is the u. And we have the square, and then let me just put the du on the side. This right here has nothing to do with natural log. 1 over 1 plus u squared we have inverse tangent. So this is going to give us, well, inverse tangent. And we'll put on the u here, which is x squared. So just put this down, and then we are done. Put plus c. That's it. Okay, these two integrals, they can be equally easy. This one is easier though. Well, the integral of secant square x, by knowing our derivatives, we know that the derivative of regular tangent x will give us secant square x. So the answer to this is just tangent x plus c, and we are done. Well, as opposed to this right here, it's kind of hard to think about the derivative what will give us tangent square, huh? But it's okay, because let me tell you, in fact, if you look at this right here, tangent square x, we know that it's actually the same as secant square x minus 1 by the identity, right? By the identity. And of course, if you have this, you know the integral of this guy is just tangent x, and then the integral of minus 1 is just minus x, so we are done. So put plus c. All right, I know, it's of course sometimes not fair to just know from here to here, right? But this right here, you can also do it legitimately in this way. So here's the deal. So let me make a note for you guys. Suppose you start with tangent square x dx. Of course, you can work with sine cosine instead. Tangent sine x over x, and in this case, you have sine square x over cosine square x dx. Now, the fair question to ask is, well, can you somehow change this? We can use an identity, yes. It would be a good idea to look at the top and rewrite this as 1 minus cosine square x. This run right here is more famous, huh? Sine square x plus cosine square x is equal to 1. So it's more famous, so this right here, it's easier for us to recognize. And when you do that, you get the integral of 1 over cosine square x, right? And then minus this over that, which is 1. So this is what we have. And of course, this is the same as that. So that's it. You can just, if you want to do a quick proof, then that's pretty much it. Secant square x minus 1, and it's just this. So that's it. Okay, we have two more integrals right here, and this time let's do this one first. 1 plus ln x over x. So this is what I'll do. I'll let u equal to the top, which is 1 plus natural log of x, and then differentiate this. Du equals the derivative of this, we get 1 over x dx. And you do see the x in the denominator and then the dx. And if you would like, you can see the cancellation by isolating the dx. Let me multiply the x on both sides. Dx will be x times du. So you can take this to a u world. This is integral. On the top is u. On the bottom is x, and the dx is x du, like this. And then the x cancel each other, of course. And you just have the integral of u du. Well, you get 1/2 u squared, and the u is that. So let's put that down. 1 plus natural log of x, and then we square this, and we are done. Put plus c right here. So this is perfectly okay, right? This is a perfectly okay answer. If you want to split the fraction, I will leave that to you. Your answer is going to look different, but the answers are just going to be off by a constant. I explained that in the past already, so yeah, I will just present this for you guys. Okay, for this one though, we do the same thing. So let's go ahead, let u equal to the whole parentheses, which is 1 plus natural log of x, and then du equals 1 over x dx, and then let's see the cancellation. We get dx equals x du. And from here we get integral 1 over x times This right here, we have the u, and then the dx is this guy, which is x du. Still cancel things out, huh? X here, they still cancel each other out. We get the integral 1 over u du. So we end up with natural log absolute value, and u is this guy, so we put down 1 plus natural log of x. We need the absolute value because 1 plus natural log of x can sometimes be negative, so you have to put in the absolute value, and you're done. Put a plus c right here. So that's it.